Hello everyone, welcome you all to the session. So here we are going to discuss about the AIET 3 JEE solutions for class 12 chemistry. Okay, so I have selected few questions for you which are very difficult and which are very important. Okay, so let's go one by one. Let's start from the first. The first question for this today's session is, which of the following has the highest electron affinity? So we are given with four options: nitrogen, oxygen, fluorine and chlorine. We need to find out which one is having the highest electron affinity. So what is meant by electron affinity? So when an isolated gaseous atom is there, and if we are adding an electron to that isolated gaseous atom, some amount of energy will be released from that atom. Okay. I am having an atom. Let me take this atom as X, which is an isolated gaseous form. And we have the nucleus. Inside the atom, we do have inner shell electrons and also some electrons in the outermost shell also. Okay. So if I am adding an electron from outside to this outermost shell, energy will be released from this atom, and that energy is called as electron affinity or electron gain enthalpy. Okay. So we are given with four elements: nitrogen, oxygen, and fluorine, and we have chlorine. Okay. So here if you see, chlorine and oxygen, chlorine will have the highest electron affinity value. Okay. Actually, across the period from left to right, electron affinity increases. And on moving down the group, electron affinity decreases. This is the general trend for electron affinity. Okay. So this is the general trend for electron affinity. But we do have some exceptional cases, right? So now if I compare fluorine and chlorine, chlorine will have the highest electron affinity value compared to fluorine because of its size. Fluorine is smaller in size. Chlorine is little bit bigger in size. So fluorine will have only 2p orbital, which is smaller in size. But the chlorine will have 3p orbital, which is bigger in size compared to 2p orbital. So addition of an electron to chlorine will be very easy, so that the electron-electron repulsion will be minimum in case of chlorine. But if you are adding an electron to fluorine, already some electrons will be there, but due to the small size, more electron-electron repulsion will be there for fluorine. So the addition of electron to fluorine will become little bit difficult compared to adding an electron to chlorine 3p orbital. Okay. So chlorine will have the highest electron affinity value. If an atom is having highest electron affinity value, then it means that we can able to add an electron to that atom so easily. Okay. So chlorine will have the highest electron affinity among these four. Okay. So option D is the correct answer for this question. Clear? So moving on to the next. Question number 38. So this is a question from organic chemistry. So we have an alkene called propene and it is treated with BD3. Actually, D here is the deuterium, okay, which is an isotope of hydrogen. Instead of BH3, you might have read some reactions with BH3, right? So they have replaced the hydrogen with the deuterium here, which is an isotope of hydrogen, and it is treated with tetrahydrofluoride, which is a solvent, and H2O2 with OH minus. So these are the reagents we see in hydroboration oxidation reaction, right? Hydroboration oxidation reaction. So in hydroboration oxidation reaction, we get the anti-Markovnikov product. We get the anti-Markovnikov product. Okay, so anti-Markovnikov means the negative part of the addition molecule will go to the carbon will go to the alkene carbon or the double bonded carbon which has more number of hydrogen atom. So that is called as anti-Markovnikov addition. Okay, so let me go with the mechanism for you so that you can understand it better. So I am going to take an alkene CH3, CH double bond, CH2. Now, first of all, this alkene is treated with BD3. Okay. So, 3 moles of alkene will react with this. Got it? And I will get CH3, single bond, CH. And here the D will go and the remaining BD3 will go to the next carbon. Okay. So, I will have CH2, BD2. So this part will be divided into D plus and BD2 minus. So the negative part will go to the carbon which has more number of hydrogen. Okay, double bonded carbon with more number of hydrogen. So it goes like this and finally after the reaction with 3 moles of propene, we'll get 3 times of this compound, okay, with boron. Okay, so boron is bonded with the 3 times of this alkyl group. Okay, so then what happens? It is treated with H2O2. So 3 moles of H2O2 will come again. Okay, so let me write the 3 moles of H2O2 like this. So this is the first molecule and this is the second molecule and this is the third molecule. Okay, so in presence of a base OH minus, the removal of H3BO3 occurs. Okay, H3BO3. So this component will come out. H3BO3 will come out and the remaining 3 OH will go and form the bond with the alkyl group. And finally, we get 3 molecules of CH3, CH, D, CH2 and OH. Okay, clear? So this particular product is given in option B. Okay, so we are getting option B as the correct answer for this question. Got it? So moving on to the next question. Question number 39. The instantaneous rate of disappearance of the MnO4 minus ion in the following reaction is 4.56 into 10 to the power minus 3 meter per second. Then the rate of appearance of I2 is. So rate of disappearance of one component is given, which is a reactant, and the rate of appearance of one of the product is been asked. So now we need to write the rate equation for this reaction. So the rate can be written as rate is equal to, with respect to MnO4 minus, it is minus 1 by 2 d of MnO4 minus divided by dt, and we have I minus H plus. But in the question, we have it is saying that MnO4 minus and I2 is involved. So we can leave those things which are going to be equal with each other. So this is equal to, with respect to I2, it is plus 1 by 5. Since I2 is the product, we have to put plus. Okay. So it is dI2 divided by dt. Okay. So now we are asked to find out the rate of appearance of I2. Means this term we have to find out. So what is this? D of I2 divided by dt is equal to 5 by 2 minus of dMnO4 minus divided by dt. Okay. And the rate of disappearance of this MnO4 minus concentration is given here in the question. I mean, this part is given in the question. So we can just directly substitute over there. So it will be 5 by 2 into 4.56 into 10 to the power minus 3 meter per second, which will be equal to 1.14 into 10 to the power minus 2 meter per second. Okay. So the rate of appearance of I2 will be option D. Just you need to equate the rate for both the component and substitute the one which is given in the question. Okay. So it's very easy question. Just direct substitution only. All right. So let's move on to the next. Question number 42. So it says that a 5% mass by volume solution of cane sugar with a molar mass 342 gram per mole is isotonic with 1% mass by volume of a solution of an unknown electrolyte. The molar mass of the unknown solute in gram per mole is. Assume that the unknown solute does not associate or dissociate. Fine. So we are provided with the 5% solution of cane sugar. So 5% solution of cane sugar means, the mass by volume solution of cane sugar means 5 gram of the cane sugar is present in 100 ml of the solution. This is the meaning. Okay. And also we are provided with 1% mass by volume of the solution. So 1% solution of the unknown solute means the unknown solute, it means that 1 gram of the solute is present in 100 ml of the solution. Okay. And also it is said that both these things are in isotonic with each other. So for isotonic solution, osmotic pressure will be equal. Osmotic pressure is represented by pi. So pi 1 will be equal to pi 2. And also we know that pi is equal to CRT. So C1 RT1 is equal to C2 RT2. So here we have to take that the temperature is constant, so that R and T will get cancelled with each other. So we are left with C1, which is going to be equal to C2, where C is the concentration. And also we know that concentration is equal to number of moles by volume, where the number of moles is equal to given mass divided by molar mass, and we have volume here. So what I can do, I can substitute everything here. So which is actually N by V, that is M divided M1 by M1 into V, which is equal to M2 divided by M2 into V. So volume is same in both the cases. Okay, in both the cases it is 100 ml. So I can just substitute the mass and molar mass. So for the first compound, the given mass is 5 gram and the molar mass is 342. And for the second component, the mass is 1 gram and the molar mass we need to find out. Okay. So from this relation, M2 will come out to be 342 by 5, which is actually equal to 68.4, and it can be approximated to 68. Okay. 68 gram per mole will be the molar mass of the unknown solute. Okay. So it is given in option C, and option C is the correct answer for this question. Got it? I hope this question is clear to all of you. Now let me move on to the next question. Question number 45. So it is again an organic chemistry question. So we have a compound which has an alkene and it is treated with HCl. We have to find out the major product of the reaction. Okay. So let me write the mechanism. So let me write the given compound first. The given compound has a 5-membered ring in the beginning, and I have a carbon with the methyl group attached, and also I have one CH3 and double bond CH2. So this is the given alkene. It is treated with HCl. So first of all, it will react with H plus in the HCl. Okay. So the alkene will go and attack the H plus and it will form a carbocation. So which carbocation will form? The hydrogen will go to which carbon? Whether to this carbon or this carbon. So it will go to the carbon from which it can form the more stable carbocation. Okay. So if it goes to carbon number 1, then we'll get a secondary carbocation. But if it goes to carbon number 2, we'll get a tertiary carbocation, which is more stable. Okay. So it will go to carbon number 2. So where C is here, and we have a CH3, single bond, CH3. So hydrogen will go here to form a carbocation here, which is tertiary carbocation, and which is stable. Okay. So now what will happen? Ring expansion will happen because 6-membered rings are more stable compared to 5-membered ring. So ring expansion will occur. So this bond will come and get attached to this carbon. So to differentiate this or to be more clear, let me number the carbon. This carbon is numbered 1 and it is numbered 2 and here 3, 4, 5 and 6. So I have taken the 6th carbon and I am going to attach the 6th carbon to the first carbon. So this step is called as ring expansion. Okay. So if I expand this, I will get a 6-membered ring with the 2 methyl groups here. And there is a carbon here and that carbon is having one CH3, a carbocation is formed at this carbon. So here this is carbon number 1, 2, 3, 4, 5 and 6. So finally I have got a carbocation in the 6th carbon. Okay, since I am breaking this bond, the carbocation will be formed at the 6th position. So now what happens? Now the Cl minus will come and attack this carbocation. It will come and attack this carbocation, leading to the formation of this product. 6-membered with the 2 CH3 at carbon number 1 and 1 CH3 at carbon number 6 and 1 Cl at carbon number 6. Okay. So this is the final product and it is given in option C. So option C is the correct answer for this question. Okay. I hope it is clear. So moving on to the next. Question number 46. The anti-Markovnikov addition of HBr is not observed in. So basically, Markovnikov and anti-Markovnikov both are not observed in symmetrical alkenes. Okay. So only for unsymmetrical alkenes, we talk about the Markovnikov addition and anti-Markovnikov addition. Okay. So for symmetrical alkenes, both the addition is not possible. So both Markovnikov and anti-Markovnikov addition, both are not observed in symmetrical alkenes. Both are not observed in symmetrical alkenes. Okay. So now we'll check for the compound. So first I have propene. Okay. So propene is an unsymmetrical alkene. So propene formula is CH3, CH, double bond, CH2. It is an unsymmetrical alkene where we can do the anti-Markovnikov addition of HBr. Coming to but-1-ene, it is CH3, CH2, CH, double bond, CH2. Again, it is unsymmetrical. Unsymmetrical means if I cut the molecule into two with respect to the double bond, I will get two unequal halves. So those molecules are called as unsymmetrical molecules. And again, anti-Markovnikov and Markovnikov can be observed here. When I come to but-2-ene, it is CH3, CH double bond, CH single bond, CH3. So here you can see the molecule is symmetrical with respect to the double bond. So it is a symmetrical alkene. So the Markovnikov and anti-Markovnikov cannot be observed. Okay. So that is the correct answer. And the pent-2-ene, if you want to check, so it is CH3, CH2, CH2, CH double bond, CH2. So again, it is an unsymmetrical. So both the addition can be observed. So only in symmetrical system, the anti-Markovnikov addition of HBr is not observed. So among the four options, but-2-ene is the symmetrical alkene. Okay. Which is the correct answer for this question. Now coming to question number 48. Which of these transition metal ions have same magnetic moment in aqueous solution? So to find out the magnetic moment, we need to find out the number of unpaired electrons, right? So to find out the number of unpaired electrons, we need the electronic configuration for these ions. So let me go for the electronic configuration first. So let me start with vanadium 3+. So vanadium 3+ has 3d2 4s0 configuration, right? And the d orbital has 2 electrons. So the number of unpaired electron will be 2, and the magnetic moment mu will be equal to root of n into n plus 2, and substitute the value for n as 2. So we will get 2 into 2 plus 2, which is root 8. Okay. Next, coming to scandium 2+. Scandium 2+ configuration is 3d1 and 4s0. Okay, so there will be 1 electron in scandium 2+, and the number of unpaired electron is 1. If I substitute 1 here in this formula, I will get the root value answer as root 3. And next, coming to copper 2+. So copper 2+ have 3d9 and 4s0 configuration. So in which the number of unpaired electron is equal to 1, because we have 5d orbitals and 9 electrons are there. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there is 1 electron, unpaired electron present here in case of the copper 2+. So n is 1 and the mu is going to be root 3. Then coming to Fe3+, the configuration of Fe3+ will be 3d5 and 4s0. So the number of unpaired electron is equal to 5. And if you substitute the value as 5 here, you will get the mu value as root 35. Okay. So from the calculated mu values, dipole moment, magnetic moment values, we can say that scandium 2+ and copper 2+ are having the same value. So option C is the correct answer. Okay. So second ion and the third ion have the same magnetic moment value. Clear? So to solve this question, you need to memorize the D block series, that 3D series elements you need to memorize from scandium till zinc. Okay. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. So if you memorize this in order, then you can go with the electrons. Like for scandium, it is 3d1, 4s2. For titanium, it is 3d2, 4s2. Like that, you can go for the electronic configuration for those elements. And according to the ions, it can remove the electron. So here for scandium, I have two plus charge, right? So I have to remove two electrons. So the configuration for scandium is 3d1 and 4s2. And since two electrons are lost here, so those two electrons will go from the 4s orbital. And we are left with only one electron in 3d. So from that, I am calculating the number of unpaired electrons and the magnetic moment. Okay. So the thing is, you need to memorize the electronic configuration for the neutral atom, then go for the ions. Okay. So I hope this question is clear to all of you. And moving on to the next question, number 53, we have 8.21 decimeter cube of NH3 at 500 Kelvin and 1 atmospheric pressure expands adiabatically up to 0.5 atmospheric pressure against a constant external pressure of 0.5 atm. And we have to assume that NH3 behaves as an ideal gas and vibrational degrees of freedoms are inactive. R value is given in terms of calorie per mole and in terms of atmospheric liter per Kelvin per. We need to find out the value of modulus of del U divided by 15 in calories. So what we have to do? So this is a numerical value question. Now let me write the given values first. So the given values are, first of all, we have volume. So volume is given as 8.21 decimeter cube. And the molecule is NH3, temperature is given. T1, the initial temperature is 500 Kelvin. And 1 atmospheric pressure, so pressure P1 is equal to 1 atm. It is expanding adiabatically. The process is adiabatic up to 0.5 atm. So the final pressure is 0.5. P2 is 0.5 atm. Okay. Against a constant external pressure. So the constant external pressure is also given as 0.5 atm. Okay. And R values are given, adiabatic process it is. So now what we need to find out? We need to find out the del U. Okay. So let me solve this. We know that del U is equal to NCV del T. Okay. So how to find out the number of moles? Using PV by RT formula. We know that PV is equal to nRT, right? Using this formula, we can find out. So the pressure is given as 1 atm and the volume is 8.21 divided by R in terms of atmospheric liter is 0.0821 and the temperature is 500 Kelvin. Okay. So the answer will come out to be 0.2. So the number of moles I have got it. And the CV value. So we know that for polyatomic species, NH3 is a polyatomic species, right? Because it has 4 atoms, 1 nitrogen and 3 hydrogen. So for polyatomic gas, the CV is equal to 3R. This is a constant value. For polyatomic gas, the CV value will be equal to 3R. And we need delta T. Delta T is nothing but T2 minus T1. Right? So we have T1, but we don't have T2. So we are supposed to find out the final temperature T2. So only if we find out that, we can able to substitute that in this formula and we can get the delta U. So now how to find out T2? So is there any other information given? Yeah, we are given with the adiabatic process, right? So what I can do, I can go for the first law of thermodynamics. So from first law of thermodynamics, we can write that del U is equal to Q plus W. And since the process is adiabatic, the heat exchange between the system and the surrounding will be equal to 0. So Q goes to 0. Since the process is adiabatic, Q goes to 0. And I'm getting a relation where del U is going to be equal to W. Okay. So this is the equation. Now we know that del U is N CB del T and W is nothing but the work done. For irreversible process, it is P external del B, which is actually V2 minus V1, which is actually can be written as V2 minus V1. So we can substitute. So N into CB del T is T2 minus T1. T1 is 500, which is equal to external pressure is given as 0.5. So it is minus 0.5. And in place of V, we can substitute NR T by P. So I can take NR out because it is common. And I am left with the T2 by P2 minus T1 by P1. Okay, so in place of B, from the ideal gas equation, PV is equal to nRT, we can substitute. So now, N will get cancelled with each other. And also in place of CV, I can substitute 3R, right? So R will also get cancelled with each other. So I am left with 3 into T2 minus 500, which is equal to minus 0.5. T2 is the one which we have to find out. T2 is 0.5 minus T1 is 500 and T1 is 1 atmospheric pressure. Now if we solve this and by taking the LCMs and all, we will get it as minus T2 plus 250. And here I have 3 T2 minus 500. Now if I bring this minus T2 to the other side, and already I have 3 T2 in the left hand side, so it will be 4 T2. And bringing this term to the other side, I will have plus 500. I mean 3 into plus 500. Okay, which is 1500 plus 250, it is 1750. So from this, T2 value will be equal to 1750 by 4, which is 437.5. This is the value of T2. So our aim is not to find out the value of T2. Our aim is to find out del U by 15, right? So we have got the value to substitute in this formula. So let me erase some parts here and then I will substitute for you. Yeah. So this is the formula which we need to use to find out the answer. So finally, del U is equal to N CB del T. So N value is 0.2, CB is 3R, and del T is 437.5 minus 500. Okay. Now, if we multiply everything, we will get the value for del U as minus 75 calorie. Okay. But we need to find out the value of modulus of del U by 15, right? So the value of modulus of del U by 15, it will be equal to, taking the modulus for minus 75, we'll get plus 75, right? So it is 75 by 15, which is equal to 5. So the final answer, value for del U by 15 is coming out to be 5. And this is the answer for this question. So basically, we are using only one formula, which is this. And we are taking out the terms, the values required to solve in that del U formula. And in that, one is not given, one term is not given, parameter is not given. And then we are finding that parameter using the other concept, which is first law of thermodynamics, and then proceeding with that, we are getting that value. And finally, we are substituting that in the equation which is being used. Okay. So the concept is easy only. The problem looks little bit bigger, but the concept that we are using here is easy. So just learn the concept, just learn the steps which we are following to approach this question. Okay, so I hope it is clear. So now let me move on to the next question. Question number 55. Assuming that seawater is 3.5% mass by mass aqueous solution of NaCl, if molality of seawater is X, then find the value of 100x. Report the answer in nearest integer form. So, here it is given that the seawater has 3.5% mass by mass solution of NaCl. So, what is the meaning? So, 3.50% mass by mass solution of NaCl means 3.5 gram of NaCl is present in 100 gram of the solution. Okay, so this is the meaning of this statement. Clear? So the mass of the NaCl, which is a solute, is 3.5 gram. So therefore, the mass of the solute is equal to 3.5 gram, and the mass of the solvent will be equal to 100 minus 3.5, which is equal to 96.5 gram. In terms of kilogram, it is 96.5 by 1000 kilogram. Okay. So now we are asked to take the molality of the seawater as X. So molality is asked to taken as X, and we need to find out the X first. Then only we can find out 100x. Okay. So the molality is taken as small m. So the formula to find out the molality is equal to number of moles of the solute divided by mass of the solvent in kilogram. Mass of the solvent in kilogram. Okay. So it will be equal to, the number of moles can be written as, the number of moles is written as the given mass divided by molar mass, right? This is the given mass divided by molar mass. The given mass of the solute is 3.5 gram. And the molar masses for NaCl we have to calculate. So for sodium, it is 23. And for chlorine, it is 35.5. So if I calculate, I will get 58.5 as the molar mass value for NaCl. So that I am going to substitute here, 58.5, and the mass of the solvent. Mass of the solvent is here, right? In terms of kilogram. So it is 96.5 by 1000, and that 1000 will go to the numerator. Okay. So now after solving this, I will get the answer as 0.620 molar solution of NaCl, which is actually the value of X. Okay. So now we can find out the 100x. Molality is equal to X, which is 0.620, and 100x is equal to, therefore 100x is equal to 100 into 0.620, which is equal to 62 molar NaCl. Okay. So the nearest integer form answer is 62 molar NaCl. Got it? Clear? So now coming to the next question. Question number 58. 90% of first order reaction was completed in 10 hours. 99.9% of the reaction is completed in X hours. find the value of X. Sorry. So now what we can do, in the question it is given that the order of the reaction is first order. So for first order reaction, the integrated rate equation can be K1, K is equal to 2.303, K is equal to 2.303. divided by T into log of A by A minus X. A is the initial concentration, X is the reactor concentration, and A minus X is the remaining concentration. Okay. So now for the first, for 90% completion of the reaction, 90% completion of the reaction, initial concentration A will be 100. And the reacted concentration, it is 90% got reacted, right? So X is equal to 90. And the time taken for this is 10 hours. Now we can substitute all the values here, and K will be equal to 2.303 divided by 10 into log of 100 by 100 minus 90, which is 10. So we can cancel this, and log 10 is equal to 1, and the K value is coming out to be 2.303 into 10 to the power minus 1 per hour. Okay. So this is the rate constant value we are getting from the given information for 90% completion. So now we have to find out for the 99.9%. Now for 99.9% completion of the reaction, initial concentration will be again equal to 100, and the reacted amount is 99.9%, and the T value we have to find out. So we can take the same integrated rate equation relation, and we can find out the T from that. Because we have already found out the value of K, right? We can substitute the value of K in that equation, and we can get the T. So it is 2.303 divided by K, which is 2.303 into 10 to the power minus 1 into log of 100 by 100 minus 99.9, which is equal to 0.1. And that 0.1 can be written as 10 to the power minus 1. And here this 100 can be written as 10 to the power 2. So if I take this 10 to the power minus 1 to the numerator, it will be 10 to the power 3. So the answer will be log of 10 to the power 3. The answer for log of 10 to the power 3 will be 3 into log 10. And log 10 is equal to 0. So what we have, and this 2.303 will get cancelled with each other. The 10 to the power minus 1, if it goes to the numerator, it will be 10 to the power 1 into 3. Into 3. So T will be 30 hours. Okay. So X value, which is the time taken, is 30 hours for the 99.9% completion of the reaction. Okay. So now let's go for the last question of this session. Question number 59. So the reaction 2A plus B giving product follows the mechanism. So we do have two reactions. One is fast and the other one is slow. We have to find out the order of the reaction. So how to find out? The rate determining step can be the slowest step. Okay, the rate of the reaction can be determined from the slowest step. So this is the rate determining step. All right. So the rate can be written as rate is equal to K into concentration of A2 into concentration of B. Let me take this equation as 1. Okay. So the rate can be determined using the slowest step, and I have written the rate equation for that, for the reactants which is given in that step. Got it? Now, we do have two reactions. One is the first one. So that is the first reaction. So from the first reaction, which is 2A giving A2, from the first reaction, the equilibrium constant can be written as equilibrium constant K can be written as K is equal to the product concentration divided by the reactants concentration raised to the stoichiometric coefficient. Okay. And from this, A2 is equal to K into A square. Okay, I have brought this term to the other side and I have got this relation. So now I have found out this K. So from K, I have got concentration of A2 and I can substitute the value which I have got for concentration of A2 here in equation 1. Okay, so I have to substitute this. Substitute the concentration of A2 value in equation 1. So it will give the rate is equal to K into the capital K into A square into the concentration of B. Okay. So in place of concentration of A2, I have substituted this. Now the small k into capital K, that can be written as K dash. Rate is equal to K dash into concentration of A2 into concentration of. So the order of the reaction with respect to A is 2 and with respect to B is 1. So the order of the reaction is 2 plus 1, which is equal to 3. The order of the reaction is 3. It is a third order reaction. Okay. I hope the session is very useful for all of you who are watching. So I meet you all with a new set of questions in the next session. Okay. Till then, take care. Bye-bye.